Thanks very much to Connected Places Catapult for allowing me to talk to you about 7 or 8 years' work with colleagues at Cardiff University to develop what I'm going to show you today. And I want to pay particular attention to the genius with which they organize an innovation session where we both talk about walking. Not bad, huh? So concentrate for a few seconds on the title. Walk through aviation security. It's a holy grail for the industry. We've been talking about it for a very, very long time, and it's not yet possible. But watch this space. Because imagine a world in which you could walk through airport security in a matter of 3 or 4 seconds. That's what we're promising. Sequestim technology is set up to do precisely that. Now, with the advent of, apologies to anybody in the aviation industry if I'm treading on your toes putting images like this up, but with the advent of the new 3D CT X-ray bag technology that's come along nicely over the last few years, and threat detection is improved, operator interface has improved, and the speed of processing of passengers has improved, and that has left the passenger screening function as the weak link in the process. Almost half of passengers require some sort of secondary intervention, pat-down, rescreening, plus all the shouting that goes on. And the vast majority of these secondary interventions are, thankfully, false alarms. The result is a process that is expensive for providers, certainly in terms of staff effort, and for the passenger, the experience is, well, let's say, just not very pleasant. You can find hundreds of cartoons like this, but it's not a laughing matter. You don't need me to remind you that the airport security is not going to be the highlight of your next trip. Now, the current generation of body scanners are stop and pose devices. You stand like this, you stand like that. The scanners irradiate the passenger, and an image or a data set is constructed from millimeter waves which are reflected or scattered from the surface of the skin. Threat detection depends on the analysis of a single image per passenger, and the algorithms, of course, understandably, are heavily weighted towards ensuring that real threats are detected. You really don't want somebody walking onto a plane with a gun when they've gone through one of these scanners. That would be embarrassing. So in consequence, the false alarm rates are quite high. And the rates at which passengers are processed is determined, in fact, largely by the number of staff the airport can afford to deploy on each body scanner. In Glasgow Airport, for example, they've calibrated for having 5 staff, 7 staff, and 9 staff per scanner. Now, the airports seek to try to strike a balance between the two scenarios you see on the screen here. On the left, you want to avoid delaying and upsetting the passengers, and on the right, you want to avoid the cost of having to deploy that many body scanners. They're hundreds of thousands of pounds each. But the airport loses both ways, because these angry and delayed passengers are not going to spend as much money when they get airside, and that's going to hit hard on their prime income stream. But above all the economic considerations, I'm sure most of us would agree that if we can put a little bit of dignity back into the security process, that won't go amiss. And over all of that, it's vital that the threat detection technology stays one pace ahead of a threat portfolio that, of course, is always developing. So what's our solution? Our unique approach is to use ultra-high sensitive detectors to perform real-time passive imaging. So we're looking at you shining at the detector, we're not irradiating you. And our patented technologies create what is essentially a security movie camera. It detects all objects beneath and between clothing. It doesn't matter what the object is made of. And the passenger simply walks by. In fact, they could run, it wouldn't matter. And we promise faster than fast track, but for everyone. A single Sequestim scanner could process 1,000 passengers per hour, and it matches the baggage traffic of a pair of the new three-dimensional X-ray bag scanners. The body scanner, I think you might just be able to make out the dimensions. It takes up 12 square meters of floor space, and it would need no more than 2 or 3 staff to operate and monitor. That represents a huge saving, as I'm sure you realize, in both equipment cost, staff cost, and floor space. So there'll be no queues, no stand and pose, no radiation, and by the way, you don't have to take your coats and jackets off. And even if you've got a thick leather motorcycle jacket, if there's a gun underneath it, I can see it. In demonstrations, we show the live output images from the scanner because it indicates the power of the capability, the power of the technique. Guns show up nicely, as you can see, but we can see much smaller, more difficult objects like wires. Single 5p coin easily shows up in the images. And the scanner acquires about 30 images per passenger as they walk through in the space of 3 seconds. And that's the critical difference. The quality and the quantity of data that we're collecting provides a huge advantage in the probabilities of detection and false alarm raising. Therefore, we're able to ignore an artifact that might show up in a single image, which would trigger an alarm in the current generation of scanners. We can ignore that and demand that an alarm is only raised if a suspect object is seen repeatedly. The detectors were invented by my CTO, who is an astronomer. Therefore, we keep him in a cage back in Cardiff University. And his day job is to put these kind of instruments on satellites like the ones you see on the right. And the detector array itself, pictured on the left there, is about the size of my hand. And we cool that to within a fraction of a degree of absolute zero in a machine that works 24/7. You could sit it in a room like this, or indeed an airport. It requires only electrical power. The detectors offer uniquely the extraordinary sensitivity and speed of detection that we need to do this moving target imaging. We calculate that the detector could easily see a 100-watt light bulb if it was on the moon. Furthermore, if that light bulb was switching itself on and off 10,000 times a second, we could watch it do so and we wouldn't miss a wink. And we use that extraordinary capability to image people just by dint of the radiation they emit because they are slightly warmer than the background, and we resolve a very small fraction of a single degree Celsius in our images. So unlike the current generation of body scanners, we don't shine anything at you. So where are we? We invited aviation security experts last summer, regulators, aviation managers, all sorts of people to come and see our demonstrator in action in Cardiff last summer. They all agreed without exception it was a capability the like they've never seen before. And we got on the telly. That's a BBC News reporter walking through the scanner with his puffer jacket on and a gun hidden underneath so he could show the people what it all looks like on the screen. And that's yours truly being interviewed. So we have a fabulous security movie camera, but I'm sure anybody who knows the industry also knows that you can't have security staff looking at these images. There's an ethical requirement that threat detection is demonstrated indirectly by presentation on an avatar. Automated threat detection is therefore a function we must add to the scanner in order to get ECAC and TSA regulation, and that we don't have. Standard AI algorithms have given us excellent results on past data sets, and here you can see a threat being identified and bounded and tracked as the person walks through the scanner. And we have our own solutions in hand, and we think we have a very nice plan. In order to complete fully functional automated threat detection, we need to operate the algorithm on a much larger data set of very appropriate data. And that means scanning a lot of real airport passengers as they go through security in the full divested phase of the process. So coats and jackets off, all your stuff in the X-ray baggage tray and all that stuff, and then we catch them walking through the scanner. And so these splendid people at CPC's Catapult have funded us to take our scanner to Glasgow Paisley Airport next month as part of the Future of Air Mobility program. And this, what you're looking at here, is a map of how this thing is all going to work in the real airport. Purple arrows are the people who don't agree to be scanned, and the green arrows are the people who are happy to be scanned. It'll be in operation for about a month, and we hope to acquire a library that's equivalent to 1 million still images of passengers. And if things proceed commercially as we plan, these scanners should be in the market around about 2026, let's say 27, just so that you don't think I'm overly optimistic. So if you happen to be flying through Glasgow Paisley Airport in the next month, I'll see you there in more ways than one. And may I encourage you to contact me at the email address shown down there if you've got any questions or you think you might want to be involved. Thank you very much for your attention.
Thanks very much, Ken. So before we put out to the room, I think we have time for one question. One question I have for you, Ken, is, so innovation like this costs a significant amount of money to implement and put through, and obviously you have big ambitious plans, as you said, to kind of launch in 2025, 26. In terms of funding kind of going forward, what's the sort of support funding-wise are you looking for going forward to visualize this long-term vision of, or execute the long-term vision of Sequestim?
Yeah, well, you won't be surprised to know that because we're a university-based research group, we've done most of the development on Innovate UK and DSTL research grants, and we've been very grateful for that. There's about £1.5 million worth gone into producing the hardware that we now have. But we're now going to be growing up and being big boys in the wide world. So Sequestim currently has a seed round, seed innovation round open, and I'm happy to say that Development Bank of Wales is offering to lead that.
Brilliant, congratulations.
So if anybody's got overly deep pockets, wants to get rid of some cash, then you know, the email's there. But we're looking for quite a hefty chunk of money to get prototypes to ECAC and TSA. So it's not for the faint-hearted, but high risk, high return, I believe is the phrase. That's
great. Listen, Ken, thanks so much. We're actually up at time now, but if anyone who's in the audience has deep pockets or watching online, there's Ken's email. I'm sure he'll be absolutely delighted to hear from you. But thanks very much for joining us for this session. We'll be doing another innovation session this afternoon at around 3 p.m. So definitely come back where you'll see 2 more SMEs from the Future of Air Mobility programme. But please give a round of applause to Ken and to Jean-Marc on their presentations.